Hello students, pleasant greetings to you all. Welcome back again to another video tutorial lesson from the AP3X Institute of Mathematics Education. My name is Akin, your math instructor. Now in today's video, it's going to be a continuation from our previous upload where we had looked at solving linear equations with one unknown. Now in part 1, we had already discussed the fundamentals of how to isolate our variable, how to keep our subject positive, which side is the best side to keep our subject on, and we went through all of the finer details. So of course be sure to check that video out, and you will of course find this video a lot more useful. However, if it is that you have already passed the fundamentals of solving equation, you can therefore go ahead and continue watching this video. Of course, my channel primarily focuses on assisting Caribbean students, not just Caribbean students, students that are doing any form of math. Any student that may be struggling, I provide contents that will help you to rebuild your foundation in math, to help you strengthen your foundation in math, and to of course apply these fundamentals to intermediate and advanced questions under the CCSLC, CSEC, SEA, CCSLC, and City and Guilds Mathematics External Curriculum. Alright, so of course, if this is the first time here on the channel, do not forget to hit that subscribe button below, turn on your post notification bell for exciting videos on a weekly, sometimes daily basis, and of course do not forget to hit the like button if you're getting any sort of value from the video. Alright, so do that for me now, and let's get right into today's lesson. Now in our last video, we had looked, as I had mentioned in the introduction, that we are looking at solving equation. This is in fact part 2, so definitely go ahead and check out part 1. So in part 2, we're going to be looking at splitting the product, and we're also going to be solving multi-step equations. Very simple multi-step equations, and hopefully then you would have had way more than enough tools and skill set to dive off into part 3, where we're going to be solving some advanced linear equations. So let's get right into it here, guys. So that's where we had left off last time. Now we're going to be learning how to split the product. Now, you're going to be solving an equation as you go through the problem from step 1 to step 2, step 3. You're going to eventually get to a point where you're going to meet up on this situation more often than not. And so here we have to isolate the variable here, say x. We need to isolate x. So the only way that we can actually do this is to actually divide both sides of the equation here by 2. And remember the importance of maintaining the same operation on both sides of the equation is to ensure that the equation is kept balanced here. So therefore then 2 will cancel 2, and then we're easily left with an answer here of x is equal to 10 divided by 2, which works out nicely here to be 5. Alright, so very simple math so far. Let's go on then next to, say here, part example 2. Now what we're doing here is that we're dividing both sides of the equation here by a negative coefficient. So the same procedure as when dividing by a positive number, same procedure as dividing by a negative number. So what we have here is minus 3 x divided by minus 3, and that's going to be equal to 9 divided by minus 3. So therefore then minus 3 cancels minus 3, so x then is equal to negative 3 here. All right, pretty easy so far, So now we're going to be looking at then how to deal with a situation then where we're dividing by a fraction. All right, so this can be done in 2 ways. All right, let us just split this up here. All right, we're going to look at doing this 2 ways in which you can approach this here. So for step 1, I'm going to be saying here dividing both sides by 3/4. So let's say we have 3 over 4 y, okay, divided by 3 over 4, and then that's going to be equal then to 15. And instead of having a division line here, we're just going to be using the division sign here. So we're going to be 15 divided by 3 over 4. All right, and so therefore then 3 over 4 will cancel 3 over 4, and so therefore we are left with y is equal to 15. Of course, when we're dividing fractions, we're going to be changing the division sign to a multiplication and inverting the last fraction. So 3 over 4 will become 4 over 3. All right. And so what we have here is that we're going to be cancelling, say here, the 3 into itself 1 time here, and 3 into 15 goes 5 times here. So we end up with a very nice solution here of y being equal to, say here, 20. 5 times 4 is 20. All right. So this is kind of like the way how you're going to find a few students doing it. They divide both sides by the fraction, but here we use the bar on the left, and we of course use the actual division sign here on the right. Now, of course, this is just one way of viewing the problem here. Let's just look at doing it another way then. So we're going to be looking at, say here, 3 over 4 y equals 15. So what we're going to do here is that we're going to multiply both sides of the equation by the denominator. So we're going to have, say here, 4 multiplied by 3 over 4 y, okay, and that's going to be equal to 15 multiplied by, say here, 4. Okay, so by multiplying both sides of the equation by the denominator, then what will happen here is that this 4 will cancel this 4, and we're now left with 3y, and that's therefore equal to 60. Okay, and so therefore then we're going to be splitting the product now by 3. So first we get rid of the 4, next we get rid of the 3. So if we divide, say here, both sides by 3, so that's going to be, say here, let's just zoom up a little bit for you. So we're going to have, say here, oops, we're going to have, say here, 3y divided by 3, and that's going to be 60 divided by 3. You're going to find, therefore, then that our final solution here is 3 cancel 3, so therefore y is equal to 60 divided by 3 is 20. All right, so what method do you prefer using? It really comes down to a personal preference. What do you feel comfortable doing? I particularly always tend to be going for here method 2 here. I find it quite easy to multiply both sides by the denominator and then splitting the product of the 3 and the y. This one also works, but it really depends on if you like working with fractions, then say here. All right, now for the purpose of the for the remaining part of the video, I'm just going to be using here, say, step or method 2. All right, so now what we have here is, in fact, say here, minus 2 over 3a is equal to 20. Then I'm going to be multiplying both sides, say here, by 3. So I'm going to have 3 multiplied by negative 2 over 3a, and that's equal to 20 multiplied by, say here, 3. All right, so cancel here, we end up with minus 2a, and that's equal to 20 times 3 is 60. So therefore then I'm going to be splitting the product of minus 2 and a here. So that's minus 2a divided by minus 2, and that's going to be equal to, say here, 60 divided by, say here, minus 2. I particularly like getting rid of the terms that are connected to my subject one by one. It may take a little bit longer for you to actually get to the answer, but I find it more effective and simpler when I'm taking step by step. So say here, 2 negative 2 cancels negative 2, so a is then equal to 60 divided by negative 2, which is equal to negative 30. All right, now the reason why I like to take step by step when I'm doing the math, of course, when you reach to an advanced level, you're going to be skipping steps because of course you know what you're doing. But at this level here, you want to take your time, go through the process step by step, that in the event that you do make an error at some point, you can easily retrace your steps to see where you might have made the error here. All right, so nice question then. Let's look at example number 5 here, and this is example number 5. Minus 3x is less than or equal to 24. Now we have to be also paying attention that we are not only going to be solving equations, we're going to be solving inequalities, and in part 1 we had discussed the importance of reversing the sign. Now we know that whenever it is that we are going to be splitting the product of an inequation by a negative number, then the sign must be reversed. Okay, the only time we do that is when we are splitting the product off by a negative coefficient. So here minus 3 will basically cancel minus 3, and so we end up with x here is, as opposed to being less than or equal to 24, it's going to be greater than or equal to 24 divided by minus 3 is minus 8. All right, beautiful. All right, beautiful. So very easy so far, not much challenge here. Now of course I'm going to have to add the whole aspect of dividing an inequation by a negative coefficient, which is actually a negative fraction. So we're mixing and mingling and intertwining all that we have learned in example 1, 2, 3, and 4 into example number 5 and 6. So here, of course, I'm going to be using the traditional method here. Say here, I'm going to be multiplying here both sides by 2. So I'm going to end up with 2 multiplied by minus 1 over 2. And that's greater than or equal to 15 multiplied by, say here, 2. So then negative 2 cancels negative 2. So I've ended up here with, say here, minus 1 times v, that's minus 1v, and that's going to be equal to 15 times 2, that is, say here, 30. All right, and so therefore then we already know that because there's a minus 1 in front of our subject, we're going to go ahead and divide by, say here, minus 1. So that's minus 1v divided by minus 1 is going to be, I made an error here, it is not equal, but it is greater than. So now I'm dividing both sides by minus 1. I'm going to have to reverse the sign, less than 30 divided by, say here, minus 1. So cancel, v is less than minus 30. All right, now of course we could have avoided dividing both sides by negative. Here we could have in fact went ahead and, let me just go up here and just show you a different route to do this here. So when we were at, say here, 2 multiplied by minus a half, okay, before we got to that state, let me just rewrite the question here. We have minus a half v is greater than 15. I could have swapped the position of the minus a half v with the 15. So I could have brought it over here and bring that over there. So what that does for me then is that it allows my subject to be, say here, positive. The coefficient of my subject to be positive. So then I would have ended up with, say here, negative 15, and that's going to be greater than positive a half v. All right, we spoke about the alternative of doing this, why it's important, why it makes it easier. Again, it really comes back down to personal preference. If you know you can remember to reverse the sign when you're dividing or multiplying by a negative coefficient, then of course you can go ahead and proceed with method 1 here. But method 2 here, you can avoid having to remember to reverse the sign. So here we're just easily going to multiply both sides by 2. So we're going to therefore then, let's just take the remaining solution down to this section here. So we're going to have multiply both sides by 2. We're going to have negative 15 multiplied by 2. Pardon me. I think I need some space here. Let's just erase this section here. Right? So then we're going to have, say here, negative 15 multiplied by 2 is therefore less than, greater than, or equal to 2 multiplied by a half v. So that this 2 cancels this 2. So therefore v then is less than, reading it in this direction, v is then less than minus 30. So you'll notice that here I have this solution here, and then this was the solution prior to this method here, and they're both signs are turning different directions, but pay attention to where the subject is at. The subject is on the side of the sign where the mouth is closed. The subject is on the side of the sign where the mouth is closed, so they're both the same answer. All right, so that is basically what you're going to be encountering more often than not as you go through various types of splitting product equations. All right, now so far in part 1 and in the introduction of part 2 here, we have learned how to isolate our terms, isolate our variables, our subject when we're adding and subtracting. We have also learned how to isolate our subject whenever we are multiplying or we are dividing. So here, introduction to part 2, we're going to be looking at some multi-step equations then. And so we're going to be looking at solving not only multi-step equations, but multi-step inequations / inequalities. All right, I'm going to kickstart this section of the video here with this inequality here. All right, now we have 5x minus 3 is less than or equal to 3x minus 1. To solve this equation, the objective here is to get all the like terms on one side of the equation. Now, according to part 1 of this video, you can definitely check that out. A link will be in the description and pinned in the comment section. Do I transpose the 5 into the direction of the 3, or do I transpose the 3 into the direction of the 5? Both methods work, but I particularly like when my subject or the coefficient of my subject is in fact, say here, positive. So in this case here, I'm going to be tempted to bring the positive 3x in the direction, say here, of the 5. So I'm going to go over here, I'm going to bring this here, and I'm going to bring the minus 3 over here. All right, so I'm going to be double transposing here. So I'm going to end up with, say here, 5x here, positive 3x comes over, becomes minus 3x, and say here less than or equal to, say here, negative 1 was already on the right side, so I'm going to bring negative 3 all the way over here as a positive 3. So then I end up here with 5x, take away 3x gives me 2x, and that's going to be less than or equal to minus 1 plus 3 is 2. And so we're back here where we're going to be splitting the product. So we're going to say here 2x divided by, say here, 2 is less than or equal to 2 divided by, say here, 2, and so cancel, x then is less than or equal to 1. Now, some students might wonder, why did I not reverse the sign? Again, the rule for reversing the sign is based on whether or not you are dividing or multiplying the inequality by a negative coefficient. Here I just divided both sides by a positive 2, so my sign will remain in the initial direction that it was pointing, then say here. All right, another example 2 here will not hurt us, just to solidify what we just did here, but this time we're going to be doing an equation instead. Again, do we transpose the 9 to the side of the 5, or do we transpose the 5 to the side of the 9? I mean, very easily, we're going to be transposing the 5x to the side of the 9, and we're going to transpose the minus 4 to that side, say here. All right, so we're going to end up here with 9x. Positive 5x comes over, becomes minus 5x. and that's going to be equal then to 7, and negative 4 goes over and becomes positive 4. Okay, so 9x take away 5x is 4x, and that's going to be equal to 7 plus 4 is 11. And so we're back again to splitting the product. So we're going to be dividing both sides here by 4. So dividing the left side by 4 and dividing the right hand side here by 4. So then 4 cancels 4 easily. Then we're left with x being equal to, say here, 11 over 4. All right, and that there is our solution. All right, so now in example number 3, now here's where, so far in example 1 and 2, you've seen where we have been transposing our unknown variable towards the left side. Here is an example now where you are going to see where we're going to have to transpose our subject to the right hand side. And why have I chosen to do this is because my objective, my ultimate aim is always to keep my variable positive, keep my unknown variable, keep my subject with a positive coefficient. It makes life easier for me. I won't have to always try to remember to reverse my sign. Again, this is personal preference. So yes, you can bring the 8 towards the left and get your answer correctly, but I'm going to change here, and I'm going to say here, bring my subject here to the right. So I'm going to bring the 3x to that side over here and bring the minus 6 all the way back over here. Okay, so let's just make it a little bit neater. So I'm going to bring the 6 all the way over here, and I'm going to bring, say here, the 3 here all the way back over here. Okay, so now on the left hand side here, I'm going to have negative 6 becoming positive 6. So that's going to be positive 6, and then that would have attached itself to positive 9, and then that's going to be equal to, say here, 8x, and positive 3x goes over, becomes minus 3x. All right, so then easily then 9 plus 6 is 15, and so 15 therefore is equal to, say here, 8x minus 3x is 5x. Again, we are back to the same situation, splitting the product. So we're going to be saying here 15 divided by, say here, 5, and that's going to be equal to 5x, say here, divided by 5, and so 5 cancels 5, therefore we end up with 15 divided by 5 is 3, and 3 is therefore equal to x. So now we are actually having an equation where we are reading from the right hand side towards, say here, the left hand side. All right, so very, very simple equation so far. All right, hopefully if you've ever had a challenge with this, you've just finally gotten through that challenge here. All right, now for this final example here, we're dealing with an inequality. So the moment you see this sign here, you've got to bear in mind of transposing, say here, the subject and keeping it positive. Remember, if your subject ends up with a negative coefficient, once you reach to the part where you have to split the product, you have to remember to reverse the sign. All right, so question is, do I bring the 4x to the side of the negative 7x, or do I bring the negative 7x to the side of the 4x? Now, this particular question was set up because I'm going to go out on a limb, and I'm going to assume that you guys are going to be transposing the 4x to the side of the 7, to the side of the negative 7x, because what I find that a lot of average or below average math students or students learning maths for the first time is that they're not paying attention to the sign that comes in front of the number. So when an average or below average student looks at this problem and I ask which is bigger, negative 7 or 4, their first answer would have been that 7 is bigger. They're not paying attention to the fact that this minus sign belongs to the 7. So in this case here, 4 is actually larger than minus 7. Every positive number is going to be bigger than a negative number. So in this case here, the best route, the safest route here is to bring the 7x over to the side where the, say here, 4x is. So we're gonna go ahead and leave the 4 here. Okay, I'm gonna bring this minus 2 all the way over to the left hand side, so minus 2 becomes positive 2. And I'm gonna keep my sign in the same direction here, and that's, I'm gonna have 4x, say here, negative 7 goes on the right hand side and becomes positive 7x then. All right, so 4 plus 2 is in fact 6, and that's going to be greater than or equal to 4x plus 7x is in fact 11x. And we're back to the same routine. We are going to go ahead here and we're going to be splitting the product. So we end up here with 6 divided by 11, and that's equal to 11x divided by 11. So we cancel the 11 here, and then finally then our solution is 6 over 11 is in fact greater than x. I do make a error here, it's not equal. I have to focus, guys. Is 6 over 11 is greater than or equal to x. So final answer here, 6 over 11 is greater than or equal to x, or you can simply say x is less than 6 over 11. All right, so that's some nice multi-step equation there for you guys. I do hope that you really get a hang of that. We're going to go ahead then and we're going to be rearranging multi-step equations. All right, so earlier we were solving multi-step equations. Now we're going to be, say here, rearranging multi-step equations. All right, guys, so we're going to be going ahead here to look at rearranging equations, multi-step equations. Earlier we were actually solving multi-step equations, getting an actual value for the unknown, but here we're going to be looking at actually solving multi-step equations by rearranging. So here we will not get an exact value for the subject. We're just going to get an expression that can be used to find the value of that subject here. All right, so here we have xt minus r is equal to v, and it says here that we need to make t the subject for t, so t needs to be isolated. Now, how do we actually solve this equation here? What we're going to be doing here is that we're going to be trying to isolate the variable one by one. So we're going to be removing first the r, then we're going to be removing the x. Now, quite a few times when I'm teaching, I find that many of my students tend to remove the wrong variable first. So some students will try to get rid of the x, then get rid of the r, or they will try to get rid of the x and the r at the same time. Remember, we can only do one at a time. So here, what is my recommendation? How do you know which one to get rid of first? Well, my rule that I use is whatever variable is closest to my subject, my intended subject, is the last variable that I get rid of. So we have minus r and we have x. X seems to be closer to, say here, t. So x will be the last thing I'm going to get rid of, say here. So this is going to be the first thing I'm going to get rid of. I'm going to be transposing, say here, minus r to this side here. So I'm going to end up with xt, and that's going to be equal to, say here, v, and negative r. I carried it over the equal sign, it becomes positive r. And so therefore then, I only have one term connected to my intended subject, which is x. So I'm going to be splitting the product of the x and the t. So we're going to have, say here, xt divided by, say here, x, and that's going to be equal to v plus r. Remember, we have to keep the equation balanced by doing the same operation on the other side, the right hand side. So then x cancels x. So the expression that we could use to find t is in fact v plus r divided by x, and that there is our final answer. All right, so we've just rearranged the equation and made t the subject. You're gonna find that many times you will have to do this sort of math. You're gonna get a very straightforward math problem, but what they're asking you to find in the question is not yet the subject, and you have to rearrange the formula to find that particular subject here. All right, now let's go on, say here to this v take away wy is less than or equal to x, and we're looking for w. Now there's a couple of things to pay attention to in this question. All right, it really boils down to your personal preference. Will you remember to reverse the sign if you're dividing by a negative subject? Or do you prefer to avoid having do you want to avoid having to remember to reverse the sign? I'm going to do it both ways because I want to make sure that this video, after watching this video, you have no problems going forward. So I'm going to go ahead here and do it one way where we're going to leave the subject negative, and then I'm going to go ahead and do it the other way by keeping the subject positive. So over here, I'm going to keep it natural. Okay, what would be the first thing that a student would probably do? They would most likely probably try to get rid of the v first. So by getting rid of the v here, we're going to simply bring the v over to that side here. Whether in front or behind, it doesn't matter. Okay, so we're going to end up with negative wy, and that's going to be less than or equal to, say here, I'm going to put down the x first and bring the v behind. So that's going to be minus v because it was positive v, so it's going to become minus v. Now I'm looking for w. That means I need to get rid of negative y. So I'm going to go ahead here and say negative wy divided by negative y. All right, and so therefore that's going to be greater than or equal to x minus v divided by negative y. All right, so therefore then the negative cancels the negative and the y cancels the y, so we end up here with w is greater than or equal to. Now if you want, you could leave the answer with a negative denominator. You're not going to find many teachers, instructors, or instructors on YouTube or anywhere. You're not going to find them leaving the answer like this. While this is okay, we kind of prefer leaving our answer all positive. So here negative y, in the negative here divides the x, turns it into negative. The negative divides the negative v, turns it into positive. So I'm going to try to write it in a positive way. So here, because the v is positive, I'm going to write it in front. And since the x is now negative, because negative into the x goes negative x, so that's negative x. And then of course I'm going to just write this all over, say here, y. So both answers are in fact correct, but most times you're going to find that we prefer writing our answer in a positive form. Okay, so I prefer writing my answer, say here, like this: v take away x divided by y. All right, now again, I particularly do not like working the math that way. I kind of prefer working the math this way. So here I'm just going to keep my v here on the left, and I'm going to therefore go ahead and try to make my subject positive almost immediately. So I'm going to go ahead and bring my, say here, negative wy. Remember, I can't just bring the w, I can't just bring the y and leave the w. The wy, they are a product together. So whatever I move, if I move the w, I have to also move the y along with it as well. So v, I'm going to therefore bring over, say here, the x on this side here. So x comes over, becomes minus x, and therefore that's going to be less than or equal to, say here, negative wy becomes positive wy. All right, now again, I don't have to reverse the sign. I don't have to reverse the sign like I did over here, because I simply have, say here, a positive coefficient, which is a positive w. So I'm going to divide the left side here by w, and I'm going to divide the right side here by, say here, w. Oh, it says 4w, so I'm going to divide by y, pardon me. So I'm going to divide by y and divide by y. So y cancels y. Guess what happens? Our answer is v take away x divided by y is less than or equal to, say here, w. And you can see that we've actually gotten the answer that we initially wrote at the bottom here. It's just that many students, a lot of students, may not necessarily be aware of how to deal with this. And whilst this is accepted, most of us are never going to write our answer with a negative denominator. It's okay, but we prefer writing it in this form. So there we have it. V minus x divided by y is less than or equal to w. Let me know your thoughts in the comment section. Which method do you find more effective? All right, let's move on down here to this expression next. We have 2a minus t is less than or equal to 12, and we're looking for a. All right, so this one is not too challenging then. We're looking then for, say here, bringing the t over to this side here. All right, so we're going to end up with, say here, 2a is less than or equal to, say here, positive t plus 12, or if you wanted to just put the t behind the 12, you could say 12 plus t. That is also fine. Remember that we're looking for a, so we're going to split the product between the 2 and the a. So we're going to go ahead here and say 2a divided by, say here, 2, and that's going to be less than or equal to t plus 12 over 2. All right, now we can cancel here, and then we end up with, say here, a is less than or equal to, say here, guess what happens? T plus 12 over 2. Now, if you kind of want to be a little bit cheeky, then you can actually say a is less than or equal to, and divide both of the terms by 2. So this would be t over 2 plus 6. If you wanted to just, show off a little bit, but I would just leave the answer as t plus 12 over 2, or you can just go ahead and say here t over 2 plus 6. Beautiful. All right, so both of those remains as our answer. Beautiful. All right, and then for our last example for this particular video here, just looking at some, just these are equations that I've just made up. They are not axioms. They're not the equation that is used to find any specific value. They're just general letters that I've come up with here just to try to, use our skill set that we've garnered in part 1 of this video. So here we're looking to find pi. Again, you notice here right away as I look at the equation, there's a negative sign in front of the pi. So just as I've showed you here in example number 2, why I really do not like to leave my subject negative, I will have to remember to reverse my sign. Now it just so happens that this is an equation, so it kind of won't affect me really. It's just that I'm going to end up with a negative denominator, and I really don't want to have to deal with that. So easily then I can just go ahead here and just transpose the pi x over to the right side and bring the b over back to the left side here. So I want to find the smoothest way to get to my answer. All right, so I'm going to end up with, say here, a small b becomes negative b, and then of course this is equal to then negative pi x becomes positive pi x, and so a take away b, becomes a take away b. All right, and then pi x is pi x. Now what we need to do here is we need to get pi to be alone. We need to isolate pi, so therefore we don't need the x to be on this side here. So we're gonna have a then take away b divided by, say here, x, and that's going to be equal to pi x divided by x. So cancel, x is gone. So we end up with a solution here that capital A take away b divided by x will give us the value of pi. All right, and that completes our video for today. All right, so splitting products whilst solving multi-step equations, key. With part 1 and part 2 of this video, you're going to find here, guys, that the solving equations going forward are going to be very easy. Coming up on the channel, you're going to find quadratic equations, simultaneous equations coming up, some simultaneous linear equations, all these wonderful types of mixture equations that are coming up. So gear up for that. Do not forget to hit the subscribe button below, turn on your post notification bell, leave some positive questions and comments down below, and do not forget to share this out to your math community. All right, all the best for your external exams coming up in 2024, in 2024, as well as in the years to come, provided when you're watching this video. So until then, take care next time. This is your boy Akin. Bye bye.